the option number 1 is to start the final earlier. So that would be probably 3 p.m. or even earlier. Or if you want it earlier, I could start it at 2 and then still end it at 5. I think I could do that. The other option is take it a day early. So Monday, but that still would need to be by 6. So I would have to do it from 4 to 6, I think. What is that, the 4th of August? And then the other option is you can take it on campus, which means you can do it whenever the testing center is open, Monday through, you would have to take it by 5 o'clock on Thursday. So think about it. Again, I'm trying to keep my tongue out of the way of my teeth. I just know I'm gonna bite my tongue. And I made the dentist numb me because I'm one of those people that even when you numb me, I still feel it when people have done like the, the general, I guess it's the general anesthesia. See, send out an email. Oh yeah, sure. Of course. I have to, because there's only 1, 2, 3, 4, 5, 6 people here, and there's 21 people in the class. Also, I saw that you like a day early. Okay, Ryan. Okay. Oh, you get probably, let's see, if I did like 2 hours. Chapter 6. You may think that it is probably the easiest. I don't know. I don't know. But most people love matrices when they begin. Matrices takes you to the advanced level because you need them for everything in engineering. The examples for matrices are quite complicated and take you into things where you are creating systems for things that operate like your phone. Is there anyone who's never seen the movie The Matrix? Let me look at the participation. You could just give me a thumbs down and say, no, I never seen The Matrix. Oh. I don't know. Now all of a sudden the participation in the chat wants to be stacked on top of each other. Why does Zoom keep changing? Every time I use Zoom, it's something different. So everybody's seen The Matrix. Okay, so the movie The Matrix is similar to actually what matrices do. A lot of programming, a lot of systems, a lot of oh, they're called feedback loops, but there are things that make things operate on like an assembly line, robotic arms and all that kind of stuff. Oh my gosh, it gets really crazy. But this right here, this problem is to link the systems of equations to matrices. So you know how like we did long division and then we use synthetic division to do it like in like a shorter way, maybe a shorthand way kind of thing. That's kind of what matrices are. And it's also because when we get to really complicated rectangular arrays systems, it is easier to use matrices. So what you put in the boxes, in these little boxes, are just the coefficients. So everything that is in front of the letter, you put in the box. So for this matrix, it's called an augmented matrix but it's really just taking the values and putting them into a rectangular array. So the first box would be 7. The second one would be 1. Third would be 7. And then that little line that is like in a column, that represents the equal sign, and then you will put the 8. So it's like it's saying that the first term is X, the second is Y, the third is Z, and then the bar and is equal to 8. So you can go ahead and see if you can finish. And you have to keep your signs consistent. Yep. Now, after she's finished, I'm going to let everybody make sure that they get to this so that you're doing it at the same time. Before she goes on to the next one. And I'm going to heat up my coffee because I don't like it when it's not hot. So I'll be right back. And also while I step away, let Kendra know if you have any questions, like what problem is that, or, just make sure you're there.
I think you muted. We can't hear you.
Me or Professor Tokens?
Professor.
I think she stepped away for a second.
You didn't
Oh,
hear you didn't hear me before?
you just cut off.
Oh yeah,
As
because I went to heat up my coffee.
oh, okay.
I just was saying if you didn't know where this was or whatever, you could just ask Kendra. This is question number 22, right? No, it's 21. Are we on 21? 21?
22.
Okay, 22. It just said 21 out of 54, so I'm like, that confused me. That's my fault. It says it right in the center, 22. I think the Novocaine's going to my brain. Anyway, and it could be tiredness. All right, so there's no questions about this, like how did this happen? How did it work? I would think that you would think it's simple, and Matrix C starts off very simple. Okay, I'll be right back and grab my. Okay, I made it very hot now. All right. So if no one has any questions, you can go ahead and click check answer and move on. All right, so the same thing here, except this matrix is going to have some zeros in place for variables that are not there. So in the first row, you can go ahead and put those numbers in there. I made it super hot. Oh my God. And then in the second row, you have no X value. So you're going to put a 0 in there for X. And then the same thing for the last one is going to be a 0 and then a 0. So for this one, you're told that Z is equal to 3. So you can take Z and plug it back into the second equation and figure out Y. And then once you have Z and Y, you can put it into the first equation and figure out what X is. Okay, go ahead and check the answer. All right, and then this one is just a little bit tricky because they don't have things lined up, but you can go ahead and do that one. think I misplaced some of my papers. Oh, I did. All right. And so no questions about this one? Like, how did she obtain anything? My other computer. Alrighty, no questions yet so far. Now, see, that's when they get like really crazy. So they introduced W, but it's just because you have I'm sorry, 5 columns. So they just introduced another variable. Pretty simple so far, yes? So it's -2 times row 1. And then you add it to row 2, and then you place it in row 2. Oh! Okay. So -2 times 1, -2, 3, and 11. And I get 2, 4, -6, and -22. And then I add it to row 2. Sorry, that's negative. And then I get 2, 3, 4, 11. So now I get the 7. Oh, 0, 7, -2, and -11. So my focus was on row 2, and I kept thinking, well, we don't usually multiply by row 2 the opposite number unless we're trying to cancel it out, and it wasn't canceling. So your two numbers should be that. Okay. And then to get 0 and 5 here, that is where I think we're multiplying -3 times row 1. And by the way, row 1, row 2, row 3. It's a good idea to label them. So -3 times row 1, I'm assuming we're going to add it to row 3 and place it in row 3. Oops, row 3. Okay, so I probably thoroughly confused you, and I didn't mean to. Because I just didn't, I was like, where are they getting these numbers? So multiply the -3 to the first row. So -3 times 1 times -2 and 3 and 11. And I get -3, 6, -9, and -33. And then I add it to this row 3, right there. So -3, 6, -9, 33. Oops, 33. And then I add it to 3, -1, 8, and 26. So when I add that, I get 0, 5, -1, and what is 33, 26, 4, and 7? That would be -7, I think. Okay, now you can ask me questions because I probably confused you. It was just really throwing me off. I'm like, why are they multiplying? Never mind.
Where did you get the -2 to multiply everything by and the -3?
So the idea is to get zeros and ones on the diagonal. Okay, so you don't really get it from somewhere. You're just kind of trying something to make it be 0 in these spots. So the program, which is probably why I was screwing it up, the program is making you do it in a way that you don't normally do, where you're just filling in blanks. Because doing matrices is kind of like, it's kind of creative in a sense that you pick what you want to eliminate. And a lot of times you pick it correctly and sometimes you pick it incorrectly and you make more work for yourself, which is what I was doing. Because I thought that they were just I thought they were eliminating and making a 0 here and here based on just row 2 and row 3. And they were using row 1. Okay, so let me know. I just want to review it if you have another question about how we got there. 3 rows. So there's a row here, there's a row here, and there's a row here. So this is row 1, this is row 2, and this is row 3. So what they're trying to get you to do is make a 0 here and a 0 here, and then whatever these two numbers are. The only thing you can do, well, not the only thing, but probably what they did was they multiplied row 2 by 1/7. So what happens when you multiply this row this row right here by 1/7? So 1/7 times 0 times 7 times -2, -2 and -11. This is where the fractions come in. So this will be 0. You already have 0 there. You have a 1. So the next one will be -2/7, and the last one should be -11/7. Mm-hmm. And don't forget it's -11. I mean, it's 11. Ah! And then the last row is 5, so is there another part? Or no. I think the only way you can get oh no, you just copy the other two. Just copy negative, because it's the same. It's 0, 5. So just copy -1 and -7. It's the same. Okay, so there wasn't another part. Okay. So a rectangular array of numbers arranged in rows and columns and placed in brackets is called it should be matrix. And then it says the numbers inside the brackets. What's your choices? The numbers inside the brackets are elements. That is a little tricky. Okay, so it says consider the following matrix. The underlying -3 can be changed to 0 if the top row of numbers is multiplied by. So what would you, do they have 2 lines in there? So what would you, this is basically what we just did. So what would you multiply the top row by to get 0? Wait, where do they want the 0? Be changed to 0 if the top row of the numbers is multiplied by. What do you think you would multiply by 1 to get a 0 if you added it to the second row? Let me see. The underline -3 can be changed to 0 if the top row is multiplied by. So what would you add to -3 to get 0? Yes. And these products are added to you would add it to the second row. Yes. Second row. Because you would add it back to the row that you, like, you want to get the 0 in that. You want to get a 0 here. So you would add it to the elements in the second row. So remember, this is row 1, row 2, and row 3. And I do recommend that you I always say read the chapter. We're not doing the whole chapter, but almost all of it. And then the same thing, so with the underlying 2, what would you multiply the top row by to get a 0? So what would you multiply this top row by to get a 0 right here? A 0 here. So what would you add to 2 to get a 0? Yes. And then you would add it to the third row. Absolutely. Is there anyone that is confused by that? Okay. And I will make another video of this. I'm gonna cut out all the part that I was screwing up. Okay, so it's the same thing as before. You're just putting the coefficients in there. They're just kind of showing you a little bit different way of looking at it. It's just a different way of looking at it because they already put what's it equal to on the one side. And then it says using Gauss-Jordan elimination to solve the system. What is the solution set? Okay, so this is going to be oh, never mind. This is really no work. This is X, this column is Y, and this is Z. So what it's saying is that X is equal to this, X is equal to this, Y is equal to this, and Z is equal to this. So that is why we want ones on the diagonal, because it means that we know what the values are. There's zeros everywhere, except for the diagonal. So first column X, second column Y, third column Z. So that's the solution. I thought they wanted us to do every step. Okay, so then this one, they do want us to watch. I mean, they do want us to do every step. All right, so the matrix here, let's see, we got 1, -9, 8, and -8. I know I am not going to have enough room. 2, we got -8. We got 0 here and 3. We got 7, -3. Oops, nope. That's a 0. 0, -3. Okay, before I get started, just check to make sure that I have everything in the right spot. And then oh, we're just writing it. Oh my God, I was getting ready to solve it. I was getting ready to go super hard. All we are doing is writing it. My bad. Just know that you're talking to somebody who overworks themselves. I do. I also printed this out and I don't have it in front of me. So going a bit off the fly. All right, so then you just need to match your matrix, your augmented matrix. 12, -6 and 3. So 2, 5, 5, 1, 2, -5. Okay, so because every single one has these zeros down here at the bottom, I'm going to try to model the multiple choice because so that means I'm going to try to get the zeros in the last column. So let me think, what would I do? So if I multiply this one, this row by -2, and then add it. So I'm gonna multiply row 3 by -2, and I'm gonna add it to row 2, and then place it in row 3. Let me think. So if I multiply that, and then I add it, I'm gonna get, what am I gonna get? I'm gonna give it a try. So -2, -4, I'm gonna get 10, and then -6. And then if I add this to row 2, 5, 5, and -6, I get 0, 1, 15, and -12. So I was placing it into row 3, but really it goes to row 2. 5, 12, 5, 12, and then row 2 now is 0, 1, 15. Oops, is that a 12 there? Yeah, 0, no, So 0, 0, 1, 15, and -12, right? But then my last column is last row. Oh, last row is 1, 2, -5, and then 3. So how do I get, Okay, I'm gonna give it a try. So -5 times, I'm gonna multiply it to this row. So -5 times row 1. I'm gonna add it to row 3. And I guess I'm gonna place it in row 3. Let me just make sure. I think so. Okay, I'm gonna give it a try. So -5, we got -10, and I'm kind of doing it in my head. Then 25, right? And then -15. I'm running out of room a little bit. And then I'm adding that to row 3, which is 5, 12, 5, and 12. So that gives me 0, 2, 30, and -3. And then multiply row 2. So my row 2, new row 2, -2 times row 2, and add it to row 3. And place it in row 3. All right, so -2 times row 2 would be 0, -2. Okay, we're getting a 0, -30. And what do we get last here? 24? Wow, this one was hard, just letting you know. Okay, so now that I have this one, I add it to row 3, so plus row 3. And I get 0, so I'm gonna say, this is row whatever it is, row whatever it is. And then 24, right? There's 24. And then I add it to row 3, so I get 0, 2, 30, and -3. And I get 0, 0, 0, and 21. Yeah, that was a little bit challenging. Mhm. There you go. Yep. Just remember, I'm gonna make a video out of this. So if any way you're lost, you just, you know, go over the book, read the book, and then watch this video. Okay, so what does this mean? It means that 0x plus 0y plus 0z is equal to 21. And we know that that's not a thing. Okay? So the solution has no solution because that doesn't make sense. So we did all of that to realize that there's no solution to this system. Okay, so we had trouble with number 33. And I had to go back and insert this part of the video. So I'm just going to use the printed out example with the solution already there for you. I'm using a different program, so the video probably switched completely. And I'm just going to have to narrate this video because I made it on Zoom, and for some reason my voice is not in the video. Okay. So you see that C is chosen. So you already know what the answer is. we get zeros on the bottom, and I think I tried to explain that in class, but it just was getting all kinds of brain twisties. So I'm going to show you that this is a dependent system. So you know what linear systems, it's when there are infinitely many solutions. And then notice that everything is in terms of z. So the x, the y, and of course the z are all in terms of z. Okay, so using the example, you see that on around the third step, we want to get zeros underneath the ones. So you see the first column, 1 and 2 zeros, and then the next column has 1 in the second row for the y value, and there's a 0 underneath there. So the first thing that we do is we swap row 1 and row 3. So when you do yours, do the same thing. Now, I don't really like how they perform operations inside of a matrix. And I think that's part of the reason why, Pearson has great ways of simplifying, solving. But sometimes I think that, us math professionals or teachers or professors, we do things in our own way. And so I'm going to do it my way. So just take notice that we want that 0 in the matrix in the second row, right, first. So I'm going to perform the operations the way that I would do it. So I'm actually going to multiply. You see it says -4 times row 1 plus row 2. Okay. So what I'm going to do is multiply -4 kind of in my head to the first row. And then -4 times 6 is -24. And then I'm going to add it to row 2. And if you notice, they did it within the same row too. And I don't like that. And now you see we have row 2. Okay? So now it's the same as what they have in the example. So just follow that step, the same with your particular problem. And so now we're going to take care of row 3, and we're just going to multiply -5 times row 1 and add it to row 3 and place it in row 3. And then in order to get a 1 in the second row, second column, we're going to multiply the entire row by 1/3. And we're going to get fractions. But we have the 1 in the correct spot. And then lastly, we're just going to multiply -3 times row 2, add it to row 3. And I'm just labeling those rows. Notice that they're the same exact numbers. That is also how you can have an intuition about what is that these are going to end up being dependent. And then you just finish. Just directly multiplying -3 times row 2, just so you can see. They did it in row 3, and it just bugs me the way that it looks. It looks like I think students would get really confused by that. So and then you see that when I add it to row 3, it again is back to what it was, but it's just the opposite. And then that's how I get my zeros. And then you write your end result. And then, so now you are just going to solve for X. You're going to solve for Y. And Z is already just Z, right? So you're just going to move everything over until you have your Y. And then you're going to take your Y, replace it with the Y in the first equation. And then that's how you have your X. So again, this is not the most useful thing in matrices. You know, I don't recall doing this much in calculus or in differential equations, but it's just another way of determining what you get when you have a dependent system. Okay, now we can go back. 34. Okay, so yeah, we can fly through some of this. Okay, so you have a matrix A, a matrix B. Now, the thing you have to be careful about is when you're adding or subtracting, you need to make sure that you're only adding the same element. So you're going to add 4 plus 0. You're going to add -2 plus whatever that is. I'm hiding it, 6. And then -8 plus 1. So that gives you the resulting matrix. So 4 plus 0, of course, is 4. -2 plus 6 is 4, and -8 plus 1 is -7. So I think you have to set up the matrix using, so when you click in the box, the little matrix button should pop up. And it is it's 3 rows, so 3 by 1. And then you can just type your answers in there. 4, I believe I believe that's correct. Any questions there? Because you do have to be careful. Now we're going to subtract them. You also have to be careful, especially with subtraction, that you make sure that you're subtracting B from A. That means A stays in place and then you subtract. So 4 minus 0. Now you can put your matrix there again, your 3 by 1. So 4 minus 0. And then -2 minus 6, which is, I'll write it, -2 minus 6. Yep. And then -8 minus 1, and I can do 4 minus 0, 2 up here. And then for the next one, you're just multiplying -2 to every element in matrix A. So you're just changing the numbers by a scalar of -2. And then, oh, sorry. And then for the last one, all you're doing is multiplying 4 to this one and 3 to this one, and then adding the numbers. So this one would be what? 16, -8, -32. And then you would add it to 0, so plus 0, 18, and 3. And then that would give you your result. Sorry, they're not exactly the same size. You know, I got Novocaine in my body. Then I put coffee in my body. And then on top of that, my face is still numb. Never want to be on stage when you go through that much stuff in one day. But it is what it is. Ugh. Okay. So for this one, okay, so with matrices, okay, I just deleted that. Okay, so with matrices, like it's similar to when you're solving an equation, but you got to be careful because the order matters. So you're actually solving for a matrix. That's why it's a big X. Okay. So there's a couple ways you can think about it. I'm trying to decide, do I want to have you use the Desmos calculator? There's a Desmos calculator that'll do all of this for you. Well, you still have to do a little bit of manipulation, but I'm going to show you the long way. And then maybe I'll show you a couple tricks on the calculator. All right, so you have your matrix A goes here and your matrix B would go here. So if you write the big 2x, what I do is I automatically subtract B from A. So you're really doing B minus A, not A minus B. So you have to be careful that you don't do it in the wrong order. So I would have the B matrix here. Sorry, I'm trying to write small and it's like, and then I'm going to subtract the A matrix. And try to make sure I don't write down anything wrong. 3 and 6. Okay. So I'm going to only subtract the same element from one another. You cannot crisscross. So you're going to subtract 8 from 0, 9 from, and you know, it's like plus 9, but I'll get there. So it's 8 minus 0. And I like to do columns. I don't know if you noticed that even though, you know, I'm loopy, I get rows and columns. I see it a certain way. So I function better with columns than I do rows. So a lot of times, I think before, maybe about 45 minutes to an hour ago, I was saying columns when I meant rows. That's because I see columns easier. Oops. Oh gosh. Oh, I don't know what just happened. Okay. I think I did something on my iPad. Oh, I did. I got rid of my pen. So 9 plus 9, right? Because it's minus minus 9, and then 1 minus 3. And then this over here would be -5 plus 7, -7 minus 6, and then 0 minus 6. All right, and then you get a result. So you get 8, 18. I'm trying to write tiny. 18, -2, 2, -13, and -6. And then your result that you get, you still have your 2x over here. So then you have to divide every single element by 2. Wait, why am I getting fractions? I hate when I get fractions. Hold on. Let me see. Because I'm looking and I'm like, wait, why am I getting fractions? Am I supposed to get fractions? I am. I'm supposed to get fractions in every place except for, no, it's only in one place. So you take every element over here and you divide it by 2. And what other computer just died? I, I was muted. Did you all hear what I said? I don't know how I got muted. I didn't mute myself. Anyway, Kendra, did you understand what I just did?
Yeah, dividing them by 2.
Okay. I don't know how I got muted. I'm looking, I'm like, why am I? Because the computer told me I was muted. I'm like, how'd that happen?
And then it'll go into like the matrix thingy again.
Yes, and this
Correct.
is a
Okay.
3 by 2.
Okay.
As long as I didn't make any math mistakes, it should be good. But I was like, why am I getting a fraction? But there you go. Trying to see how many more I can do. Okay. And then that one is just -13 divided by 2. I think, let's see if it's right. I think Pearson allows you, let's see if it's right first. I think Pearson allows you to do -6.5, but because I've seen students do that and I'm like, oh, it came out right. But I don't know. It doesn't
I was
really
say
have,
some of them they're tricky. Some of them it will,
yes.
some of them it won't.
Yes. Okay, so I am going to show you with the calculator this one.
Okay.
So what you need to do is write down both of those matrices. I need to write them down too. So it's 5x plus 3a equals b. Okay, so really what's going to end up happening, right? And I'm going to write it out. So write down both of those matrices, and then I'm going to show you how to use the calculator to help you with this. So 5x equals b minus 3a, and then x is equal to b minus 3a, oops, equals over 5. So I need to write that down. I mean, I guess it'll still be on the screen. Okay, so when you get finished writing that down, go to, Google Desmos matrix, and as soon as you type that, it's gonna say Desmos matrix calculator.
Okay.
Okay, I wrote down, and then you have your numbers. So I didn't write down your numbers, I just wrote down the ending result.
Yeah, so let me. Yeah, I might have to stop sharing for a second because it's
It's okay.
or
And we're a little bit over time, so if you need to go, you can go, but I'm gonna keep going for a little bit longer. Just because I wanna, like, it's just me. I wanna get to at least 40, maybe 40 something. Mm-hmm. Okay, so you remember your numbers, right? So just click new matrix. It's automatically gonna make it A. And then you need to change, was it
it was
3?
3 by 2.
3 by 2. Okay. And just type in the numbers. And then hit enter. And then you're going to type in matrix B. Okay. So now you can do, I'm going to do it kind of in a little bit of a chunk. So you can do B. So you can type, literally, you can click the letter B
Mhm.
down below.
I like here.
Minus 3, and then A, right? And it automatically gives you the answers, and then you can hit enter. And then I believe, no, you might not be able to do it. So there's two things you could do. Let's try it. So
Mm.
do parentheses, then do B minus 3A again, and then go outside the parentheses and hit divide by 5. And then you can change everything to a fraction. Do you see the little fraction button next to the matrix? Yeah.
Oh, nice.
Yeah. So I think I picked that one. I mean, I purposely pick challenging ones, and then sometimes I look back at it and I'm like, what in the world is going on here? But this one is just I think I picked it to teach you how to use the calculator because nobody wants to do fractions.
Right.
They don't have to. So I believe that would be, let me see. What number is that for you?
36.
6. Let me make sure, because usually the example, well, yep, it's fractions.
Mhm.
So, yep,
So then that would be the answer to that one.
that would be the answer to that one.
Awesome.
Now, of course, I suffered and learned how to do it all by hand, but we have tools now and there's no point in suffering. I mean, unless you want to do it. I mean, there's some people, I kind of did torture myself a little bit. I did every problem that I could. Um, because that was the only time I was like really competitive. So I wanted to make sure the professor could not take any points from me. So um it was like a contest in a way in my head.
Mhm. I feel like too, though, it's always nice to know how to do both. Because sometimes, I mean, it's nice to have a calculator, but then sometimes you don't have one.
Well, the for me, the calculator really is to make sure that I can be more efficient and that I can still show work, but not have to, like, if you don't know what you're doing, you would have gotten some crazy answer. It would have been like these weird decimals. It wouldn't have been so easy to make it into a fraction.
Let me
So,
try.
yeah.
That gives me a similar one. Then A equals. This is problem 37.
Okay. Yeah, so for this one, I'd say B minus 4A. It's a little different. And then
Mhm.
I would put the X on the other side, but you can interchange them as long as you keep it in the right order.
Oh, -7. Okay. And you said
So it would be B and then minus 4A. Yeah, because there was nothing in front of the X, so it's not like you had to divide this time.
yeah, it's definitely a lot faster.
Hmm.
Trying to figure her out. These kind of remind me of the like Sudoku puzzles, kind of
Really?
in a way. I don't think they're extremely similar. I think it's just the columns, but like that type of getting them to equal a certain.
Mm-hmm.
I'm still on 35 and I keep getting it wrong.
Okay. Um,
I can go back to sharing 35.
all right, so
I even try to use the Desmos, but I don't know what I'm doing.
oh, okay. So do you want to give Kendra your numbers and she can just do it on the Desmos calculator? You can just follow her.
Okay.
So, Kendra, go back to the calculator and then
This one is the one that you switched that it says 2x plus a equals b, but it comes out to be like a minus b, and then we divide by 2.
no, it's B minus A. You got to be careful. Let me show you on the screen. That I figured that might be what it is. So the equation that they give you is 2x plus A equals B, right? So when you're talking about matrices, order really matters. So if I subtract A from both sides, you have to make sure it's B minus A in the calculator. So it's the matrix B minus the matrix A, and then you divide them by
Okay.
2. So you can give her your numbers.
I got it now. I had all this my
Oh, you
signs
got it?
because I had it backwards.
I figured that's what it was. It happens. All right, let's see. Where are we at?
We're at 38. Put that in here.
Yep. It has a bunch of negatives, so definitely use the calculator. Let's see, 39, 40. Okay, so our goal is 40, and then we'll stop. And then the rest I'm gonna have to do a video. And 38 is
Then
Oh.
it would be
so it's 5a minus
plus, or yeah,
b divided by 3. And you can do it all in one shot. So you can do parentheses, 5a.
so my numbers are a little different. So 5a mine's 2b.
Oh, 2b. Okay.
Yeah.
And then
And then
that,
divided by from
that in
parentheses
parentheses first. There you go. And then
And
divide by.
by 2.
And again, the calculator is a whole nother skill because if you would have not used parentheses, sometimes the answer is goofy. I don't know if I mentioned, but they put a whole new tooth in my mouth. It's a fake tooth for for 2 weeks.
We're all going in.
Yeah, they I don't know, they shaved my tooth down and put some filling thing on it, and then they put a cap on it.
You
So
got a
I
crown?
I got a crown. I got a whole new tooth. It's my second one. So I think it's because I eat a lot of almonds. So I guess I'm gonna have to stop eating almonds or I'm gonna crack all my teeth.
I just got a crown like 2 months ago, and it was literally the most worst experience of my entire life. I had to get like 4 shots of lidocaine. I still felt it. My nerves in my neck were still jumping, and I had a whole panic attack and started bawling, and the dentist had no idea what to do.
Are you serious?
It was so bad. Well, when I went to go get the actual cap on, they didn't numb me. He was like, "I'm gonna try to do it without numbing," and I was like, "Okay." Well, the first time that we did this, like to get the tooth shaved down, I was having problems with numbing, and it was the most sensitive. And I don't. You said they had one before. The first thing they do when they take the temporary off is take a bristle brush and grind the rest of the cement off of your tooth. And it was like an open tooth, and I literally ripped her whole hand out of my mouth, and I was like, that hurt really, really
Oh,
bad.
you're better than me.
It
I
was
felt
Oh
what a bitter.
my,
The funny thing is, Professor, when you emailed that, I was at the dentist too.
oh my God.
I swear, I'm sitting there in the dentist chair. She goes, I read all I saw, what came up as a notification. I'm having sort of emergency at the dentist. I'm like, oh, that's funny. Mine was just a cleaning, but that was terrifying in itself because I'm terrified of the dentist from past traumas that's happened.
Oh my God, I'm so sorry. I'm so sorry.
You were good. You were good. It was me sitting in the chair today for my cleaning. You were fine. But I'm like, hey, at least we're in it together. I mean,
Oh my God. No, but Mackenzie, I'm one of those people too that feel stuff even though they numb me. So to actually really feel it after you've been numb that many times is
yeah.
really, that's like really crazy to me. That's crazy to me because I
See,
told him that. I said, listen, I'm one of those people who I've been in surgery before. And I'm like, I feel you cutting me. He's like,
yeah.
really? So he
Then
gave me some kind of extra, so that's why my whole face is like
the
it feels
next time
like
I go to the dentist, I will 100% say I need numbed because he did. He looked right at me. He goes, "We're gonna try it without lidocaine at first." And literally, well, first of all,
oh,
my teeth like close. I have a really small jaw, so the temporary cap is smaller than the real one, like the actual metal one. So when he tried to pull it out of my mouth, they had to like shave it and break it because my teeth closed in on it. Yeah, I'm not kidding. It was literally
This
the
is why
most
I don't like
traumatic
the dentist.
experience ever. It was so bad.
This
I
is
cried twice. The first time when I like was having a full-blown panic attack, he was like, "You look sad." And then all of a sudden I just started bawling and I couldn't breathe. And he was like, "I'm gonna give you a minute." And like and then he comes back and he goes, "Do you want numbed?" I said, "Yes, I need numbed."
oh
Because
my
they did
god.
the reason I had the panic attack is because they did the whole thing and my mouth wasn't dry enough because he couldn't blow air in on it because it was so sensitive.
oh my
And
God.
it didn't set right, so he ripped it off right away. Well, whenever they put the binding on it, if you're not numbed, you feel every ounce of it and it burns so bad. Like my ears were ringing. It was so terrible.
Oh my God.
It was
Yeah,
so terrible. And
that hurt.
I had Invisalign and I had like these things that pulled my teeth back. Well, these bars, well, when he cracked them off of my teeth, it left a sensitive spot at the top. And I told you I was in the Air National Guard. Well, I had to go to the base in Carlisle, and it's like just young airmen. It's not their fault. They're just young airmen or army people who don't really know what they're doing yet. And I told
Mhm.
him, because I know that, I told him, I said, "Don't stick the pick in this spot." I said, "It is very sensitive." And literally right after he sticks it in the freaking hole, I said, "I just told you not to do that."
Oh my God.
I am done I will get my cleanings, but just like Kendra said, even cleanings now, I'm like, please
It's
don't touch
traumatizing.
anything.
I
Oh my.
literally, I sat there today. I made my best friend come with me because last time I went by myself, I tried to leave in the waiting room.
Yeah,
They
it's
took too long to
terrible.
come and get me, and my mind started going. And I'm like, nope, I gotta go. Like I guarantee you, like I'm under as a flight risk at that office
Oh
because
my God.
today when I came in, they took me right back. I didn't even get to sit in the chair.
Yeah, it's super
Oh
terrible.
my God. Well, I'm glad to know that I'm not the only one because you know exactly what I'm talking about then. Cause
Yeah.
like yeah. And
I'm
it's just A times B. So just big A times big B. And then vice versa. Mm-hmm. Um, yeah,
I
wow.
have a question. How do
Mm-hmm.
you, okay, so I'm on question 37 now.
Mm-hmm.
How do you know, like when I put it in here, this one says solve the matrix equation for b minus x equals 4a. Do I always need to get the equation to be x equals b? Like, do I always need to get b and a on the same side
Yes.
before I put it into the
Yes. But
calculator?
but be careful. So you're saying that yours is B minus X equals 4A.
Yes, ma'am.
So then you just swap these two. So do B minus 4A equals X. That's the easiest way to put it in the calculator.
Okay.
And then Kendra, you see all you have to do is just A times B, B times A.
Mhm.
Now when I do the video, I will show you how to do the
How do I
multiplication by hand.
how do I put it in as an answer?
Um, so your first one is going to be go back to the Pearson.
Oh wait. I see it. Okay, never mind. I'm with
Yeah,
it.
you just do a 3 by 3 and then a
Yep.
2.
I had a complete brain malfunction there for a second.
It's okay. And then I'll try to do a little bit of the theory about multiplication. Multiplication is where it starts to get difficult. Um, but
I'm glad I stayed on to learn how to use this dang calculator.
I know. That's what I'm saying.
You don't even want to know how many times I've cried over math.
oh no.
Me too, girl.
I am a crier. I literally just start sobbing.
Oh no.
And I hate Pearson's, whatever, because it wants it like so particular, like the answer in like a particular way. I'm like, I had the answer. I'm crying for no reason.
Yeah, the amount of times that's happened to me too.
It makes me so upset.
Because I'm like, how is this wrong? And then I see like, oh, I forgot a parenthesis. Like, I'm
Yep.
looking at the numbers.
I make mistakes all the time. Like earlier, I'm looking at the example and I'm not really following it because I'm such a scanner. I'm scanning it. And then I'm loopy from this day. And I'm just like, what am I doing wrong? What am I doing wrong? I'm like, oh, I needed to follow exactly how you wanted me to do it. And that's not normally how I do matrices, but it is what it is.
Can I switch? I'm switching back.
Like we wanted ones on the diagonal from left to right. This time we want zero. So you can put whatever number in there.
In like the top.
Yep. You can put whatever number. Don't make them really big, but you can put whatever number there.
4
And then the next one you put 0.
below it. Or no, next, or you mean next to the 4.
It doesn't matter which one. 0
Yeah.
there, and then under the 4 a 0. And then the other one, whatever number you want. And then go outside of that bracket. So just hit the right arrow until you're outside of it. And then hit the times button. And then you're going to do another 2 by 2. So did you hit times? Yeah, there you go. And then another 2 by 2. Yep. And then so you want to do the same thing. You want another matrix that looks like just like that, but you can make up your own numbers for the actual numbers. The other two are zeros, just like the first one.
Just keep the zeros. Okay.
So it's like a little tricky thing because it's the only time, or it's supposed to be the only time where you're going to get the same result when you multiply it either way, because order matters with matrices. So A times B equals B times A. It's the only time that you're supposed to get the same result.
Okay. The only thing I was confused because it says use a comma to separate matrices as needed.
Oh, is it a comma? Sorry, it's a comma. You're
good.
right.
Instead of the multiplication.
You're so right.
I wouldn't have known.
That means it's 2 different ones. My bad.
I got it. No, you're good.
Okay. And
Okay,
then
that makes sense.
let's see.
And now
You can handle that one. That's the same thing as before. Click 42. Let's see what that looks like. Same thing. You can use the calculator. Let's see, 43.
Same thing.
Same thing. 44, same thing. You see, I'm making you do multiplication a lot. Okay, that is where it changes. So I'm gonna do the video because I'm gonna stop here. I'm gonna do the video. I think it was 34 that I was having trouble finishing.
Or 33.
What was it? 35?
33.
33? Okay. Yeah, 33. And then so I'll start at 33 and then I'll go 45 to the end. Okay, so for this next part, I'm going to use my iPad. I'm going to use the Pearson book just to go over matrices and then hopefully make one more video on determinants. So again, this is in addition to the Zoom. So again, for some reason, it did not record my voice. So I'm just going to go to some of the parts where you can look at your book. I recommend that you read your book. I recommend that you do all of the problems in this section, especially if you're going to higher levels of mathematics, especially if you're going into engineering or something like pre-med, because you probably have to take Calc 2. So it just helps you organization wise. So if you look here, you guys should be good up into number 4. into number 5 based on the Zoom that I did. But notations in matrices, solving and multiplying matrices can kind of be tricky. So just have a look over that so that you know all of the definitions and etc. And then you can read some of the applications with matrices. So adding and subtracting matrices is pretty much straightforward. Look over some of the definitions, what they mean. It goes in a little bit more detail with the I and J. One is a row, one's a column. And that means, the placement in the matrix, the element in the matrix. But just have a good read over that. And then scalar multiplication is the same as distributing. And then we multiply by something, and then multiply the matrix by something, and then we add or subtract. So there's some of the properties of scalar multiplication and how they work. It's kind of like the distributive property. Remember, with matrix equations, you have to be careful. Order matters. So please make sure that you are careful about that. We did some of those in the previous parts of this recording. And then traditionally, how I learned how to do matrix multiplication, which is where it starts to get a little bit more difficult. We always start with 2 by 2 matrices. I recommend that, you do the examples in the book. But if you notice that you're moving where you see the first row, you're moving down the column. So you're going from A times E, and then you're adding B times G. Okay? And then notice where it says the definition of a matrix multiplication, how each element is placed, right? So it says row 1 of A times column 1 of B, right? So you have to be really, really careful. So just notice where everything is, and then, you know, I always recommend that you write down every example that you are not sure about. But I took a screenshot of that so you can see. Okay, and I'm going to choose, since I took a screenshot, I'm going to choose a different pencil point. So notice that where you have the 2 and the 4, that's the first column in the first matrix. But the 0 and the 5 is the first column in the second matrix, but it's written kind of in the row position. So just notice that. So 2, 4, 3, 7 is the first matrix, and that's written in the work next to the equal sign. But the 0 and the 5 are copied. So that is how I've learned how to keep track, because matrices, doing them by hand can be, I won't say confusing, but you can get lost sometimes. So that's why it's a good idea to start with a 2x2. And then just read over more of the definitions of matrix multiplication and do more examples. In example 6, they want you to notice that A times B is also B times A. Well, you're going to actually find that out. That's usually how you learn how to do these kind of problems. So notice that how we write what type of, or what the size of the matrix is. So this is a 1x3, and B is a 3x1, right? So just pointing out which one is which. So if the middle numbers are the same, then you can multiply them together. If they are not the same, you cannot do it. So just notice what happens in the rest of it. And then what you end up with is a 1x1. So the outer numbers tell you which size matrix you're going to have in the end. And then if you look on the side here, you see technology, your TI-84. I wish it would specify that, that the TI-84 can perform these operations for you. And then we have some properties of matrix multiplication. Read that over. And then there's an application. Okay, so back to the work. This is a 3x2. And we're multiplying it to a 2x3. And I'm going to show you how to do it by hand. So just follow along. So you already can see the results. So when you do yours, just be really, really careful. When you have signs, they can make a lot of mistakes. So just be careful. But, you can also use the calculator to verify your answer. So I would say do it by hand and then do B times A, to see what you get. But, you can always verify your answer with the Desmos matrix calculator. Now, when determining the multiplicative inverse, we went through some of those, I believe, in the Zoom. So again, you can verify those using the Desmos calculator. You can do them by hand. Just pick which one you want to do. Now, you can easily Google the matrix calculator for Desmos. So you make your matrix by clicking new matrix, or you can actually, you have to pick your size, but here we are just doing or verifying with using the problem that was in our document. So you just type in your matrix A, your matrix B, and what's so nice is that you can see your matrix, and you can end up seeing your result when you multiply A times B immediately. And then you just do B times A. All right. And remember, you always have the option of doing it by hand. And then here, same thing. Now, when it comes to this one, you can type in your matrix and you can find out what the inverse is of your matrix also. But I also can encourage you to go back to the book, read the multiplicative identity matrix, right? And you can see those elements, A11, A12, it means row 1, column 1. So those little sub numbers, they mean something. They're the elements and what placement they are in the matrix. So the multiplicative inverse, if I multiply 2 times a half, I get 1. So it's vice versa. So that's kind of the idea here. A times A inverse is the multiplicative inverse or the identity matrix. So you can look at that. And then you see that if it is actually true, we would get ones on the diagonal, right? So the identity would be those ones on the diagonal. And then I want you to also notice that when you look at A and then you look at B, well, A has the same numbers in them, except that the diagonal, those numbers are switched and they also are negative. Okay? So just take note of that. I think it's pretty interesting how that works. So again, using the calculator, and you don't have to call it A or B. You can call it a new matrix C. You put the numbers in. and then you say C and to the -1, and then you can just click the fraction button, and it gives you your answer. And then the same goes for the next problem. And the number 48, you do not want to do that by hand. I mean, if you really want to, you can, but it's a lot of work, especially with all those negatives in there. And then you have the 4x4. That's a lot too. Now again, learning how to do it by hand, they give you an example and they separate the numbers and your inverse, your multiplicative inverse with letters, right? So they kind of show you what you're actually, like how you're getting there, okay? And they're using kind of the systems of equations to show you how that works. And then they're showing you an example using the multiplicative inverse of a 2x2 matrix. The 1 divided by A times D minus B times C is called the determinant. They don't actually tell you that yet, but that is what we call the determinant. And then they show you how to do it with a 3x3. It's pretty much a lot. And then lastly, they show you an application for matrices. All right, so for this one, they actually give you the inverse, so you don't have to find it. And then you have to use that and multiply it to the what it's set equal to, your constant matrix, and then you just perform those operations, right? You realize this is a 3x3 and you have a 3x1, so you know that you're going to end up with so you have 3x3, right? So 3x1. So you have 3x3 and you multiply it to a 3x1, so you're going to end up with a 3x1. So you just use your rules. Notice that the second number in every single multiplication is 0, 1, and 8. So anything times 0, that column is gone, and then you just add the rest of them, and you end up with what you get in the solution set. So 4, -3, and 7. As always, I hope this video helped. Sometimes it can be rough editing, but I do my best. Don't forget to like, share, and subscribe, and I will see you next time. Thank you for watching.